So I'm going to show you your group member, and why don't you move around to sit together as a group, okay? For practice, this is your group. Can you see that? Have a seat together as a group. The main reason I'm rearranging the seat, tomorrow I'm going to give you some paperwork. Okay, basically based on the history of math, you're supposed to develop some discussion. But before having a discussion next Wednesday, I'm going to give you some small paperwork, okay, document. You're supposed to fill in by yourself after reading all the documents, just about 2 pages, but in English. So basically I'm going to give you some history of math about calculus. So that's why I emphasized, you need to know mathematics first before taking this course. You should understand all the content related to history of math about calculus. So next Wednesday, I'm going to collect all individual work. Basically, I already asked several questions before, after, but you need to follow the sequences. So I'm going to collect all the documents, and next Wednesday, based on your individual thought, we are supposed to have a group discussion like this. So we are going to move to new building of College of Education for a 2. I'm going to explain later, but next Wednesday, you are not going to meet here, okay? We are going to move to next building, new building, do you know, for a 2. And because, this is not a good sitting format for discussion. That's why I'm going to move to 402 in new building of College of Education. And then we are going to have a group discussion. After having a group discussion, I'm going to collect your opinion. I'm going to call your name by computer system instead of me. Because, I have some preference. That's why I'm going to restrict to my subjectification. Okay? So, anyway, any question regarding next Wednesday group discussion? Yes. No. Just only next Wednesday for group discussion. Okay? Because this is not, as I said, good sitting format for group discussion, because you're supposed to have a small group discussion. After finishing a small group discussion, we are going to have a whole class classroom discussion. But in order to have a small group discussion, I prefer to have a sit together, facing together, in your group, your group member, and then that's much more, I think, comfortable for group discussion. That's why I'm changing classroom just only one time. Okay? So next Wednesday, only one time classroom change. Okay? Other class we are going to meet here. Make sense to you? By the way, don't miss the next Wednesday class, because based on your group discussion, I'm going to ask you to write your group member's name, all your group members' name who participate in group discussion. I'm going to grade a part of the miscellaneous item, which is part of your whole final grade. If you're going to miss next Wednesday class, I'm going to give you just 0 credit for that. Also, if you do not submit next Wednesday before having a group discussion, you're supposed to submit your individual work on the document. Okay? I'm going to collect all 57. If I'm going to miss, I'm not going to give you any credit to that. Make sense to you? You need to bring after reading all the document, you need to fill out, the old answer in the document. Last time, in relation to storytelling, I emphasized how to visualize the information based on history of math. Can you remember? So, first of all, I show you the example of square root of 2, right? I emphasized probably real life story can be improved, right? Can improve student conceptual understanding. That's why I show you the example of square root 2. Second one, second example about the pi, right? Is going to show you or your student, how a mathematical concept can be developed historically. Those kind of concepts, can improve student probably conceptual understanding as well as some motivational factor. And the third exam, what was it? Can you remember? The video clip, the third one. Binary notation, right? I show you by using a binary notation the usefulness of mathematical concept in real life context. The final example, integer factorization and prime number. I try to explain basically the need for the meaning of mathematical process in real life context by using this example. You just need to refresh your memory about storytelling for history of math. All those 4 video clip make sensible to you? I really hope you enjoyed it. Today, I'm going to shift my focus on storytelling for letters and equation. What is a letter? What is equation? You need to operationalize by yourself all terms related to math education. That's going to be help you to understand all content related to math education in depth. So think about what kind of definition can you make for letters and equation. As you know, this kind of concept middle school students are supposed to cover, right? And probably first grade, second grade as well, and middle school. I'm going to structuralize in this part of 4 different kind of topic. First of all, I'm going to briefly explain what kind of advantage of using letter. Okay? And second one, based on history of math, I'm going to explain why have those rules for the use of letter been developed. Okay, I'm going to answer that question indirectly. Also, the third part, I'm going to explain, the need for prediction equation. Basically, why equation needed? Why middle school students are supposed to learn the concept of equation? I'm going to try to answer that question. Finally, another example might be useful to use storytelling for letter and equation. Equation as effective models for real life context. First of all, take a look at several points about advantage of using letter. If a middle school student would ask me, what are the advantages of using letter in learning mathematics? So what do you think? Do you have any opinion about that? No, Jiwan? What do you think? If your student asks you what kind of advantage of using letter in learning mathematics, then what kind of answer can you provide? I think middle school student may ask you, right, while you are teaching. So why you are supposed to use the letter, A, B, C, or X, Y, Z? What do you think? Any idea about that?
그냥 일반화된 개념들이 있으면 다른 상황에도 적용하기 쉬울 것 같아서.
So that's a good point. So many math educators, commonly pointed out at least two important points in terms of why you are using letters. One is, as you pointed out, generalization. The other is abstraction. Do you understand? Two terms. One is generalization. The other is abstraction. These two kind of key concepts you should understand. If you're not familiar with these two terms, you should find yourself. Okay, this is not the coursework to explain math education term. So, but this is basic term you should understand. If you took any math education course, you should understand this term. Right, 지혜? Abstraction, right? Generalization. I explained enough last semester, I think. So anyway, you need to check by yourself. I think, but consequently, I can explain probably 4 steps. First of all, by using letter, I think we can simplify mathematical idea. Do you agree upon this perspective? Right? We can simplify, right? How many, for instance, apple, we can just put X, right? Instead of how many apples. Otherwise, we need to solve by using how many apples, right? So anyway, you can simplify mathematical idea. What about next one? Make mathematical computation succinct and simple. Do you agree upon this perspective as well? Right? Quadratic equation, for instance, x squared minus without using letter, right? How can you compute this kind of complicated situation, right? That's why any mathematical computation related to, especially in complicated situation, I'm going to show you more example later at the end of class. But anyway, just a simple example of quadratic equation or just a linear equation. What about third one? As I said, a generalization of results about the mathematical idea, right? If you're going to solve any mathematical problem by using symbol, right? Those results, right? From those results can be applied to another situation if you connect each other more precisely. That's why even though you cannot generalize all the results, right? But you can generalize some results. Finally, diverse approach to generalization can provide new insight into mathematical principle. Do you agree upon this as well? So think about, any mathematical principle, right? Algebra analysis or topology, right? A different approach, from time to time, different approaches to the same concept can give you new insight into mathematical principle. Think about this kind of advantage of using letter. Anyway, this is my thought. Maybe you can develop your own thought about advantage of using letter. Anything else, do you think? Except this? More creative? Sungum, you're thinking a lot. So, do you have any ideas rather than this for perspective in terms of advantage of using letter? If you do have, you may suggest later. So, I'm going to update my PowerPoint. Anyway, I really hope you enjoyed, this kind of advantage of using letter. Probably, to middle school students, you may use this kind of perspective. Why? You're supposed to use the letter. Maybe in middle school, right? To the first grader, you can explain by using this kind of perspective. Take a look at. In mathematics, we are supposed to use the letter, right? In middle school. But this kind of advantage you may use for your students' better understanding of letter and equation. Take a look at Descartes' perspective. Am I correct, by the way? So instead of translating Korean into English, I prefer just to use Korean for your better understanding. Please take a look at and read. Anyway, this is Descartes' perspective. What kind of advantage of using letter? Make sense to you? Anyway, this is Descartes' perspective on advantage of using letter. Jiyoung, can you read? Can you read on the back side? It is clear? It's readable? I just want to make sure, Anyway, so think by yourself, how to explain. If your student asks you what kind of advantage of using letter in learning mathematics. Another thing to make storytelling for letter and equation, you might use history of math to explain rule for the use of letter. Have you ever thought about this? Why do we omit the multiplication symbol as in 3a equal 12? Any answers or any idea? from elementary school to middle school, right? Kid might be confusing this one, right? Should be used. Because in elementary school, they always use 2 times 3 equal to 6, right? But this is multiplication. But in middle school, all of a sudden, we are using what? Right? What do you think? You have never thought about this issue before? You may think about it.
결합법칙이랑 교환법칙이 성립하기 때문에 쓸 수 있는 거 아닌가? 그러니까 더하기도 뭐 굳이 쓴다면 쓸 수 있는데 곱셈, 그러니까 점을 쓰려면요 무조건 교환법칙이랑 결합법칙이 성립해야 돼요. 왜냐면 순서가 바뀌어서 단값이 똑같으려면은 그러니까 생략해도 문제가 생기잖아요. 무조건 두 가지 법칙이 성립해야 돼요.
Right. That's a good point in terms of computation process, right? So, but you may add this kind of perspective from Japanese mathematician. Take a look at it. Make sense to you? Anyway, this is the Japanese mathematician perspective. Why you're supposed to use for plus, minus, right? Division, right? Symbolically they used, right? But you are omit multiplication symbol. Anyway, so by the way, I'm going to upload every PowerPoint on the website, our course website, EKU. You can check, okay? So don't write down in my class, the content. Maybe you may have different perspective, and then you may write down. But in terms of PowerPoint, you can take a look at on the website. Okay. What about this one? Why 2a instead of a2? Have you ever thought about this issue before? Not at all. So I'm explaining, this kind of rule issue in terms of basic algebra. Just think about, storytelling, right? Storytelling for letter and equation. You may develop some, storytelling, based on history of math. Okay, take a look at this issue, because students are supposed to follow the rule, right? Even some teacher, as far as I know, deduct some point if students are not following the rule, mathematical rule. But the student may have no idea why this kind of rule you are supposed to follow, right? Before explaining, before emphasizing those kind of rule in terms of using letter and equation, you may explain, right? Based on history or based on some storytelling method, why we are supposed to follow this kind of rule. Make sense? That's why I'm explaining based on history what kind of storytelling is possible behind the history of math related to this kind of rule. Anyway, this is kind of interesting perspective, but it makes sense to me. Think about where it comes from 2a, right? I think it's going to be from European perspective. That's why 2a. Why not a2? And you think about it, this rule. What about this question? I think maybe some of you are already familiar with. Why we are supposed to use the constant ABC and unknown quantity XYZ? I intentionally used unknown quantity. What is the differences between unknown quantity and variable? Why I prefer using, in this case, unknown quantity instead of variable. What is the differences between unknown quantities and variable? I just want to clarify the meaning of these two terms. Guy, what is the differences between these two terms? Unknown quantity and variable.
unknown quantities는 미지수라고 해서 모르는 variable은 변수니까 변화를 주는.
Do you understand? That's the differences. Therefore, I used unknown quantity here, x, y, z. Take a look at, for instance, Viette. Actually, he used vowel and consonant to indicate unknown and known quantity respectively. This is the rule. About 400 years ago. But this is not the rule we are following right now, right? Make sense? If you take a look at probably 400 years ago mathematics textbook, they used A, E, I, O, U for unknown quantity instead of X, Y, Z. Then Descartes developed use of ABC to indicate constant and use of X, Y, Z to indicate unknown quantity. So this is the influence of Descartes on mathematics historically. But after explaining these two different perspectives, right? ABC and X, Y, Z rules, can be changed. But we need to follow, traditional method. That's why we are following, we are using ABC for constants, X, Y, Z for unknown quantity. Make sense to you? Anyway, this is interesting, story where there are many theories about this issue. Why we are supposed to use X rather than Y and Z for unknown quantity often. Do you know? But some teacher may use Y and Z instead of X. For instance, just how many apples. So we have 20 apples, but one of my friends ate 7 apples. How many apples left? So what kind of symbol usually use? You use, I think, X, right? Instead of Y or Z. Why we often use X? Historically, I think several theories possible. One theory, the Arabic word for unknown quantity was shay in English. When European later translates Arabic word into Greek, shay become XEI. The word is abbreviated to X. That's the one story, or one theory, why we are using X. As an unknown quantity, we often use X. But another possibility is that Descartes adapted X from Z. Probably Descartes often used X for unknown quantity. But another possibility is X and Y are the easiest character to write with a feather dipped in ink. What is that? Around at that time, right? Just in terms of publication or printout, some symbol, X is the most convenient one. I don't know which is the truth, but you can see different story, right? About the same issue. Anyway, take a look at the different kind of story about why you are using unknown quantity, often as x. Make sense to you? Storytelling for letter. You need to think about, maybe you may develop some, a video clip as well. But, you can think about, what kind of advantage, right? In terms of using letter in learning mathematics, you can develop some, story about this. Or you can develop some storytelling methods about why we often use this kind of rule, right? I just explained 4 different kind of rules. You may think about it in learning mathematics. I hope it's useful information for you. At least you can use, why we often use the X, Y, Z, right? Based on history of math in your teaching. Even though next Thursday, I invited, mathematician, whose major is biology. I think next Thursday, he is going to explain how mathematics can be used in mathematical biology. Okay? He's going to discuss, in depth, how mathematics can be applied to real life context. Next Thursday, so he's going to present about 60 minutes, and then I'm going to give you time to ask any question regarding presentation next Thursday. But before doing that, think about some storytelling methods about prediction equation. I really hope it's going to be fun for you to watch this video clip. Take a look at it. Basically, storytelling for equation. What kind of storytelling can you use in your class to explain equation?
생명현상 하나하나가 우주만큼 복잡했습니다. 그러나 현대 수학이 조심스러운 첫 발을 내디뎠습니다. 생명의 세계는 난폭하기도 합니다. 질서가 없어 보이기도 합니다. 그러나 질서와 법칙을 찾는 수학이 이제 생명현상으로 눈을 돌렸습니다. 그것은 동물의 외형에 관한 질문으로 출발합니다. 왜 어떤 동물은 무늬를 가지는데 다른 동물은 무늬가 없는 것일까? 또 무늬를 가진 동물은 왜 서로 다른 패턴을 가지는 것일까? 무늬를 생성하는 원리가 존재할까? 그 속에도 수학적 법칙은 숨어 있을까? 답은 치타가 가지고 있습니다. 왜 치타는 사자 같은 무늬나 얼룩말 같은 무늬를 만들지 않았을까요? (2002년) 수학계에서 그 답을 담고 있는 2권의 책이 출판되었습니다.
Our daughter was, she was about 5, and I was reading to her a story by Kipling called How the Leopard Gets Its Spots.
모레이 교수가 딸에게 읽어준 동화책의 주인공은 원래 무늬가 없던 표범이었습니다. 표범을 가엽게 여긴 친구가 손도장을 찍어줘 표범이 지금의 얼룩무늬를 갖게 되었다는 내용이었습니다.
And at the end of it, she said, how do they get their spots? I said, I have no idea, but I will past my colleagues in Oxford. And no one knew. And I got interested in it and started to work on maize around 1970. Well, I was curious about why some animals were spotted, some were striped, some had uniform color.
연구를 시작한 머레이는 곧 동물의 무늬가 생성되는 과정을 방정식으로 기술할 수 있다고 믿었습니다. 그러나 그가 먼저 만나야 했던 것은 숫자와 기호가 아닌 화학물질이었습니다. 동물의 무늬를 만들어내는 것이 바로 화학물질이었기 때문입니다. 멜라노사이트라는 색소세포에서 생성된 멜라닌은 동물의 털이나 피부로 옮겨집니다. 이 멜라닌으로 동물은 다양한 털의 색깔을 만들어냅니다.
And Jerry said, what happens is you've got, think of the surface of the animal when it's very small, when it's an embryo. There are biological chemicals which are reacting and they're also moving around inside the surface. And this combination of the chemical reaction and movement, the diffusion,
동물의 무늬를 만들어내는 화학물질. 그 상호작용에 대한 튜링의 방정식은 이렇게 비유할 수 있습니다. 숲은 언제라도 불이 날 것처럼 바싹 메말라 있습니다. 불은 무늬를 만드는 하나의 화학물질로 비유됩니다. 불이 번지지 않도록 헬기는 불 주위에 물을 뿌립니다. 헬기는 불을 억제하는 또 다른 화학물질로 비유할 수 있습니다. 불과 소방 헬기의 대결이 끝나고 드디어 불이 꺼집니다. 숲은 그을린 자국으로 가득합니다. 두 화학물질의 반응과 확산이 남긴 무늬입니다. 튜링은 동물의 무늬가 이런 화학물질의 작용으로 생성될 것이라 상상했습니다. 그런데 상상으로만 여겨졌던 이 방정식이 곧 증명되었습니다. 실제 화학 실험을 통해서였습니다.
And this was probably the first very obvious demonstration that the reaction, the equations, chemicals reacting and diffusing could produce spatial patterns, both temporal and rotating. It was a very exciting work.
구소련의 한 화학자가 실제로 진행한 시험입니다. 화학물질은 튜링의 계산대로 확산하고 반응했습니다. 튜링의 이론이 상상이 아니라 실제한다는 것이 증명되는 순간이었습니다. 그보다 작은 태양은 그만큼의 반응을 담습니다. 그리고 태아가 아주 작으면 하나의 반응 속에 묻힙니다. 확산과 반응에 관한 튜링의 이론이 화학 실험으로 증명되었고 머레이는 그것이 실제 동물의 무늬에 적용될 수 있다는 가능성을 보여주었습니다. 이제 마지막으로 등장하는 질문이 있습니다. 코끼리처럼 무늬가 없는 동물입니다.
When the pattern formation mechanism is activated, it could be, the embryo could be really quite large, and that would be the equivalent of trying to get a pattern or a sound rather out of some enormous drum, or throwing a stone into a pond. You get little waves, but very quickly they all die out. So if you look at the pond as a whole, you don't see any pattern.
무늬가 생성될 때 코끼리의 태아는 너무 커서 셀 수 없을 만큼 많은 반응을 담습니다. 결국 이 반응은 태아에 묻혀 흔적을 잃어버립니다. 만약 이때 코끼리의 태아가 좀 더 작았더라면 어땠을까요? 아마 우리는 전무늬나 줄무늬를 가진 코끼리를 보고 있을지도 모릅니다. 물론 수학자들은 그 속에 숨겨진 방정식을 생각하고 있겠죠. 화학물질의 반응과 확산, 태아의 크기에 따른 무늬의 발생, 그리고 논리적으로 이것을 설명하는 방정식, 이것들이 동물의 무늬 속에 숨어있던 보이지 않는 원칙들입니다. 생명의 세계에도 원리가 있다고 믿는 수학자들의 탐구가 결국 생명 현상의 깊은 곳을 보이는 것으로 제시했습니다. 보이지 않는 것에 대한 질문. 수학자의 이 질문은 반세기가 넘어서 그 가능성이 열렸습니다. 수학자들은 포식자와 먹이 사이의 법칙도 방정식으로 풀어냅니다. 튜링이 화학물질의 확산과 반응을 수학 공식으로 설명했듯이 말이죠.
그렇다면 수학적으로 설명한다는 말은 무슨 뜻일까요? 왜 수학자들은 평이한 말로 풀어 설명하지 않고 수학 공식을 사용할까요? 예를 들어 보겠습니다. 사과 3개가 있는데 2개를 먹었더니 하나가 남았다라는 표현이 있다고 하죠. 수학자들은 아마도 3 빼기 2는 1이다 라고 표현할 겁니다. 첫 번째 표현이 더 쉬워 보이지만 여러 가지 오해의 소지가 있습니다. 사과 하나를 다 먹지 않고 남기면 어떨지, 사과 하나가 썩어 있으면 어떨지. 하지만 두 번째 표현은 사과 3개 중에 2개를 완전히 먹었고 하나만 온전히 남았다라는 전혀 오해의 소지가 없는 훌륭한 표현입니다. 수학적인 표현을 쓰면 큰 보너스를 얻게 되기도 합니다. 예를 들어 보겠습니다. 이곳 마사이 마라의 누떼수가 증가하면 사자수가 늘어납니다. 먹잇감이 풍부해지니까요. 사자수가 늘어나면 누떼수는 줍니다. 많이 잡아먹히니까요. 자, 이렇게 평이한 말로 표현하면 누떼수의 변화와 사자수의 변화를 쉽게 이해할 수 있습니다. 하지만 수학자들은 같은 현상을 포획자 먹이 방정식이라고 하는 조금 복잡해 보이는 수학 방정식으로 표현합니다.
이 방정식은 수학자들이 이미 잘 개발해둔 방식으로 풀 수 있고 누떼수와 사자수가 어떻게 변할지를 예측하게 해줍니다. 이제 우리는 2개월 뒤에 누가 몇 마리 있을지, 3개월 뒤에 사자수는 어찌 될지, 예측할 수 있습니다. 이렇듯 방정식이 가진 힘 중에 하나는 예측입니다.
It's fun to watch. Just 9 minutes you spent, but I think you learned a lot, right, from the video clip. I hope, by using, this kind of, storytelling methods, you can improve your students, imagination as well as creativity. Also, you can show, how mathematics can be applied to real life context, especially related to mathematical biology, right? Here is a more fun video about decision making. So basically a story about storytelling for equation as effective model for real life context. But the main point, how to remove emotional factor or something. Take a look at it. Another methods.
£20, 30, 40, £50. That's yours, okay?
우리는 자유의지로 내린 이성적 판단에 따라 이 프로그램을 본다고 생각한다. 하지만 이 남자 생각은 다르다. 자기가 좋아하는 사진을 고르는 건 간단한 일 같다. 하지만 이 남자들은 그렇지 않을 거라고 말한다.
Just a little bit like a hobbit.
우리는 이 프로그램을 보는 게 지금이 처음이라고 생각한다. 하지만 이 남자는 그렇지 않을 수도 있다고 말한다. 우리에게 미래를 보는 능력이 있기 때문에 미래를 보는 능력. 뭔가를 선택하는 건 언제나 쉽지 않다. 선택하는 기술이 부족하기 때문이다. 하지만 다행히도 이 남자는 수학을 이용해 우리를 구해줄 수 있다고 한다.
I have almost like a 95% chance with this girl. Looks like maybe you could buy those shoes. Does that sound good? Would you buy it?
That's the right answer.
그러니까 이 프로그램을 보기로 결정한 우리는 흥분하다. 이게 인생 최고의 선택일지도 모른다.
Definitely greater than one. You'd be better off if you watched Horizon.
Working that up.
우리는 매일 수천 가지의 선택을 한다. 하지만 과학자들은 그중 상당수가 잘못된 선택일 수 있다고 말한다.
Most of the time we're behaving online, we're behaving in the flow of the moment, we're faced with this uncertain world, and we're doing the best we can. And often we're wrong.
우리의 현실 파악 능력은 우리가 생각하는 것만큼 정확하지 않다.
We think we have a stronger awareness of our surrounding and our choices and the reasons for our actions than we actually have.
그래도 절망하긴 이르다. 이런 문제점을 알아낸 과학이 우리를 도와주기 때문이다.
It works. It does. If I don't use it, I'll quite often make the wrong decision.
과학은 우리의 선택에 대해 어떤 얘기를 해줄까? 이성적인 판단을 내리는 법을 함께 알아보자. 이 청년들은 컴퓨터과학, 공학도, 로켓 과학자들이다. 이들에게 공통적인 고민이 있다.
I feel like a creative person who's been logically trained through my engineering degree. I've always been interested in how things work and I've always taken things apart.
어디를 보나 괜찮은 청년들 같지만 이들에게는 여자나 친구가 없다.
I'm the president of a LAN gaming group where a bunch of guys get together and play games.
My favorite ones are like strategic type games, like I like ruling the world. Those are the fun type games.
Play lots of golf and console group? No.
청년들은 외로운 인생의 종지부를 찍기로 했다.
문제는 컴퓨터 게임을 하며 지낸 시간이 너무 길어서 마음에 드는 여자한테 접근하는 법을 잊어버렸다는 점이다. 이제 여자를 만나는 것조차 망설여진다. 다행히 제작진은 도움의 손길을 찾아냈다. 직업도 과학자와 사촌지간이다. 괴짜 수학자인 가스 썬뎀은 자신에게 어울리는 여자친구 찾기 같은 일상의 문제들을 수학으로 해결할 수 있다고 말한다.
Decision making in mathematics, it's strange. They share exactly the same language. You have a problem that you want to solve, and you look at the factors that you're going to weigh against each other to solve this problem. It's really the same language.
선택과 수학의 공통점에 착안한 가스 썬뎀은 일상적인 선택들에 적용할 공식들을 만들어 책을 펴냈다. 그는 이성적인 결론에 다다르려면 모든 변수들을 비교해보고 변수들이 공식 안에서 상호작용하게 만들어야 한다고 주장한다.
My chances of getting a date with someone would depend on factors like how attractive you are, how attractive they are. That would be an obvious ratio comparison right there that would affect your chances of getting a date. So you guys have all been downstairs. There's someone in your mind that you're thinking about. So now we're going to go through and figure out what your chances are. Okay? We're going to see what the math says. How witty of a conversationalist are you on a scale of 1 to 10?
I'm fantastic.
What do you guys think?
그 여자하고 잘 될까라는 질문에 적용되는 공식엔 몇 가지 변수가 있다. 말주변 같은 사교술, 이성을 사귄 경험, 그리고 제일 중요한 매력이다.
How attractive is this guy? What do you think? 8? 8? Okay, we'll give him an 8. We'll give him an 8 as key. Now, how attractive is she on a scale of 1 to 10?
7.5.
7.5? No, we call that 7.
7.
Okay, 7.
자신과 상대방의 매력 지수는 공식에서 제일 중요한 변수다. 마음에 드는 여성보다 자신이 더 매력적이라면 그 여자와 데이트할 가능성이 높아진다.
Here we got 1, 1.4. We're going to pretty much call this 9. 35. You have almost like a 95% chance with this girl. And we're really thrilled with that. The fact that you're actually more attractive to this girl. You're a very big conversationalist. You're pretty much like a dream guy. Does that sound right to you guys?
다른 청년들도 가스 썬뎀의 공식에 따라 마음속으로 점치는 여자와 데이트를 할 확률을 계산했다.
Okay, Levi, Danny, ready for the math?
No, I don't want math.
You should want to do the math?
No, I can do it on my own.
Okay, no math to mess up your Jedi mojo.
No.
Okay, go on, totally do that. So we got like 95%, we got 43%, we got 41%, and we got heck with percent. I'm just gonna go to it. Sounds good to me. Let's see how it goes.
가스 썬뎀도 선택이 적용할 공식들을 만들며 이 모든 변수를 검토했다. 썬뎀은 새로 만든 공식을 갖고 감정의 영향을 가장 많이 받는 판단 중 하나를 도와주러 나선다.
These are my favorites so far.
Okay, would you like some help deciding?
But what is this?
Okay, I'm coming over. Okay. So here's what we're gonna do. How attractive would you consider yourself right now?
I'll give myself a 5.
Solid 10.
Solid 10. That's like in this context, sort of Sarah Jessica Parker.
가스 썬뎀이 고안해온 이번 공식의 변수에는 구두의 가격과 발의 편안함뿐만 아니라 구두 구매가 소비자한테 주는 정서적 만족감까지도 포함된다.
I would be a 7.
So it would change it by at least 2.
Yeah.
Cool.
Say a 7.
Okay, bump you up a bunch on that scale.
전망 이론에서 빌려온 흥미로운 변수도 있다.
Are you seeing anybody right now? Are you not married?
I'm not married.
Okay.
I'm married.
Married, okay, married.
You're dating.
Living together?
No,
Okay.
감정의 영향을 가장
I'll say a 7.
Okay, above.
I don't know, some part is missing. Anyway, so I hope you really enjoyed it. So by the way, so out of 4 guys, right? Do you know what is the result? In the video, the results, the last guy who didn't use the mathematical formula, actually he failed. Other 3 guys successful. Because they explain before meeting a girl, they already know the formula, right? Oh, I do have 41% or 48% or 90%. Therefore, their reaction has been changed before meeting. That's why 3 guys successful, but the last guy who didn't use the mathematical formula, he's failed. Anyway, just for your information. So did you see 2 different kind of video clip about storytelling for equation, right? The first one is what? Do you remember what is the first video clip? Cheetah equation, right? The second one is the mathematical formula, right, for decision making, right? So the first question, do you know what about the probability of being able to date with someone? This kind of formula, right? It's a little bit complicated though, but as you can see, ability to speak, experience to date, attraction. How to reduce our emotional factor in buying new shoes. He developed this kind of formula. Buy shoes, how comfortable is, budget, increase in attraction, and marriage status. Even it's complicated, but it's still doable, right? In terms of developing a formula, decision-making formula. I hope you really enjoyed the second video clip. Anyway, I tried to explain, storytelling for letters and equation. By using, just making stories about the advantage of using letter, right? The first, storytelling methods can improve, student interest in mathematics, or student, some, creativity as well. Also, making story about the rule for the use of letter can make mathematics more accessible to students, right? Because they don't have to memorize all those kind of rules. They can experience by using storytelling methods. Oh, that's why we are using this kind of rule. That makes sense. And then maybe mathematics more accessible. The third one, story about the need for prediction equation to make more accessible, more sensible, to students, right? Because equation itself is not abstract itself, right? Or equation is just the only abstract concept, right? Equation can be applied real life context. Equation itself says us something, right, regarding real life situation. So finally, story about equation as effective model for real life context, can improve student creativity in learning mathematics by using second video clip, right? Maybe we can improve student imagination as well as creativity in learning mathematics, right? They can develop their own formula, right? For instance, what am I going to do to develop some formula related to my real life problem, right? Make sense to you? As I said, so next Wednesday, you're supposed to meet room 402 in new building of College of Education, next building, okay? So don't forget it. So any question regarding the contents? I always try to 5 minutes left over before the end of class. The main reason I want to give you a chance for you to ask any questions. Any question? As a pre-service teacher, it's not that easy, right? Before the end of class, you need to left some time. Any questions? Yes. Yes. We do have only 2 buildings, right? This one and next one, isn't it? Any other questions? So anyway, so don't forget, tomorrow I'm going to give you some paperwork, okay? During the weekend until next Wednesday, you're supposed to fill in the paper, okay, by yourself. And you think about, history of math, about the calculus. And then I asked, several questions, so you need to answer by yourself, okay? And then based on the paper, even though I'm going to collect those papers, you can remember, right, what you wrote. Based on those content, we are going to have a small group discussion. After finishing a small group discussion, I'm going to have whole classroom discussion. Okay, that's the next Wednesday class. By the way, tomorrow I'm going to explain Pythagorean theorem. How can we use storytelling methods for Pythagorean theorem? Okay, that's the tomorrow content. Following Wednesday, as I said, we are going to have a group discussion about storytelling methods about calculus. Next Thursday, we are going to invite mathematician whose major is mathematical biology. We are going to have a chance to listen, what he's talking about, usefulness of mathematics in real life context. Okay, that's the this week plan and next week plan. Okay, that's all for today.